Hello everyone. In this assignment we will discuss about how we can import raw data that we measure in with our setup. In this case, the distance that we measured with the ultrasonic sensors, and we also would use this to analyze and how to present it in such a way that is meaningful for the reader of our reports. So when we are measuring data, as we could see here, we measure lots of data, and this was an example of our not a big large experiment. Sometimes we might end up with hundreds of thousands of or millions of data points, or even larger. So it's very hard to represent all of them meaningfully. So the way we do it generally, we are extracting averages, and each one represents a category, and in this case most of the time, like we can see here, for example, for this type of distances we thought it would be like 10 inches. We are representing all those data points there with a mean value, and also with a confidence interval 95%. This is a useful confidence interval in engineering, and this represents two standard deviations from the mean value. So that tells us that 95 points out of 100, if we have to perform, are sitting within this interval that is called confidence interval. So how the first step that we learn, and the first procedure that we learn most of the time, is how we read data sheets. I mean, spreadsheets with data. So in this case, we did use a comma-separated file when we saved our data, when we took the data, took the measurements, and we can see that we can use load text, and that's the name of our file. And then we have to mention, because the text might contain different other delimiters. In this case, a space could be a delimiter, but in our case, it was, as the file tells us, a comma-separated data. It's so between 2 points, data points is a comma, and because we are using a header, we don't want to introduce that there, so because it's not a number, so we skip that row. So we have to tell it that, and then we start to assign values. And we know that the first column was time, and the second column for us it was the measured distance. Again, one point here, not to forget, that indexing in Python and C and Lavi and maybe other software starts from 0. In MATLAB it does start from 1 on an octave, but in these ones that we are using here, it starts from 0. So the first column is 0 and the second column is 1. So after we are doing this, that we want to basically separate these data points, because we don't want to take the average value for all of them. That's meaningless if we do that. So we were at 1 inch, that we want to know what is the mean value here, what is the standard deviation here. So how do we do this? In my situation, I did use 20. I went to measure from 1 inch all the way to 20 inches. And in that case, I know how many, I knew the increments, and it's very good to use a for loop in this situation, because I know how many steps I have in the measurements that I took. So as you guys can see, this is a very well to say for I, the number of iteration, in the range from 1 to 21, and the last one is omitted generally in Python. So this is the start value, the end value, and because we are incrementing in the with 1, then we omitted this case, but the most of the time right here, if we don't go from 1 to 1 in increments of 1, then we go in increments of 2, then we don't have to omit that, so we have to put a 2 there. But by default, we can do this because the step is 1. Then when we are separating this, what we are doing is that we try to make using this where function, which is a logical AND. In this has several parameters in that where function. We're using give me the points that are within that distance from 1 minus 0.5, which means 0.5 to 1.5 inches. So in other words, within this range, any points that's there separate them, extract them. I want that point, and then we calculate the average and then the standard deviation. That's exactly what it gets. So this function gives us the indexes for that from the whole column of distance, and then we sort them. We don't want the indexes, we are after the values. So after we get the values, then we calculate the mean basically value for out of all those values, and then we calculate the standard deviation. And then as we can see, we don't want to do only for this position, we want to do for all of them. So that's in this case we append that value in an array that we call it means, and the standard deviation in an array that we call it standard deviation. And in this case, as you can see, after we are stacking all those, we want to plot them. So in order to plot them, we have to kind of generate the x-axis, and we assume that we know the true values. Unfortunately, for our case, it was not accurate, and the true value, I called it here true value because we assume we were 1 inch, we were 3 inches, and we did our best to put our blocks at those distances. So in order to do that, we want to an array from 1 to 21. So instead of just making an array where we write like 1, 2, 3, 4, 5 all the way to 20, I just build an array with a linearly spaced value from 1 to 20, and you see I put here how many intervals I have. I have 20, in total. So that's a shorter way to generate an array of these values. Then as we know that we wanted a confidence interval, and this is 95% in engineering is meaningful for us, that confidence interval. That's why we have to use 2 standard deviation. To the left, as you can see here, this is my mean value right here in the middle. Then for 95%, so what we are expecting is mean 2 standard deviations to the left and 2 standard deviations to the right. If we use only one, then only 68 points out of 100 we fall in this interval. So that's a 68% confidence interval. But that's not too meaningful, not helpful in engineering. Most of by convention, we're using the 95. Much better probability is for 3 standard deviation to the left and 3 standard, but that would be an overkill for our measurement. So it would be 99%, almost 100% accuracy. So and that's what we are using. So after we do that, then we plot the values. We plot our mean values, and we use error bars in order to show those confidence intervals. So that's what we put on x-axis, the true values that we assume as the true values. We use the mean values as our to represent that marker where the mean value sits, and then we have the confidence interval as our standard error bars, from that mean value, how far we are. And I put as a format for my marker is with blue and a round circle, and I didn't want any face color into that marker, because sometimes, as you can see right here, for example, my error bars are my confidence is so small that if I put a color here, I will not see it, so that's and this is after I zoomed in. So you guys can see that sometimes the measurements are very, very accurate, very precise. So that's why most of the time we leave that empty, so we can see here. And I use the color for the bars with red. Generally, it's not the way to do it, so I use it just to show in evidence here what is it. So please, whenever you're doing in your reports, use the same color as the marker. If the marker is blue, use blue. And then you guys can see that this I need to define this. If I ignore this, by default, it will not put that bar, horizontal bar on the top, so I have to tell it how large it will be, cap size. So these are just some formatting features that help us to beautify our plots. And you can see that I put the label because I want to put I said that is measured because I wanted to put a legend, so that's useful. And then I wanted to show just how far we were from the assumed true value. That's what we did here. So I put here I plotted true value versus true value. So if I was a 2, I assume I was a 2, but the average was not exactly a 2. So you can see it was a little bit farther from that, just for sake of comparison. So and sometimes what happens when we are plotting these things, we also, if we make this smaller, for example, we have this problem with the margins. So in order to, again, beautify our plot and see our axes, names of the axes, we kind of use these margins. We set the margins for our axis, and this is exactly what is done here with the, what is the first margin here for this left point. This is for the other margin here, and then you have how far you go from that to the right in x-axis and upwards, and that those two are here. So this is very useful, and ideally, basically, we're idle. We are using. We have to put this because otherwise, if we forget to put it, we will not see the plot. That's how it is. If you use other like PyCharming or either like a Spider, you might not need to put that. But in this case, with idle, you have to do it. I hope this video tutorial was very useful for you, and if you have any questions, please let me know. Send me an email at g.punjet@maristate.edu. Thank you.